All right, question 15 of tutorial 2. So here we have an implicit function, right? So we have an equation that relates x, y, and z, and we are supposed to differentiate z with respect to x and z with respect to y from that equation, right? And basically, the idea is that we have one equation and three variables, so we've got 2 degrees of freedom, so which means that well, any two variables can be chosen as those 2 degrees of freedom. And since here, well, the objective of the question is to find partial derivatives of z with respect to x and y, it means that x and y are independent variables and z is the dependent variable. All right, so z here, sorry. So z here is supposed to be a function of x and y. So z is a function of x and y. All right, now the right hand side of our um, equation. So we denote it as f of x, y, z. So our equation defines a surface in the 3D space, and it is a level surface of this function f of x, y, z, because the right hand side is a constant. If the right hand side was not a constant, then we would have to move it to the left hand side so that something equals a constant. All right, how do we do that? Now, well, in order to find partial derivatives of z with respect to x and y, we've got to differentiate our left-hand side of our original equation with respect to all the three variables, x, y, and z. And so we've got to find partial derivative of f with respect to x, which is x, y, z. Differentiating with respect to x, y and z are constants, so we just get y, z. Plus, we have a fraction here, so it's going to be minus 1 over x plus z squared. So fy is going to be xz. There is no y in the second term, so it's partial derivative is 0, and fz is going to be xy minus 1 over x plus z squared. Okay, so that's basically it. And how do we find the partial derivative of z with respect to x? We just need to use the formula from the lecture. It's minus fx divided by fy. So fx is, so minus sign here, yz minus 1 over x plus z squared. So I've just copied fx divided by fzx. So sorry, it should be fy, of course. Sorry, fz. All right. So, and then now I've got to insert this. So it's going to be x y minus 1 over x plus z squared. And I guess probably in order to sort of simplify it, we can multiply both numerator and denominator by x plus z squared. Doing that, we will get minus yz times x plus z squared minus 1 divided by xy times x plus z squared minus 1. Okay, and now we will do z y in the same fashion, so it's going to be minus fy divided by fz, so which is minus. Now I'm going to copy fy, which is just xz divided by fz, and again, so this is my fz, xy minus 1 over x plus z squared, which is minus, I guess I will just multiply by x plus z squared, again both numerator and denominator, so it's going to be xz times x plus z squared divided by xy times x plus z squared minus 1. And basically, that's the final answer. I don't think that you can simplify it any further.